Alright, so where we left off last time, we were able to write one character from the microcontroller to the OSRAM display. And basically I just added some methods to write to the other digits. You can basically just copy this whole thing and put it into a new function. And then the only thing you have to change, remember, is A0, A1, and A2 from the data sheet. Digit 1, we've already done digit 0, which is A2 high bit, A1 low, A0 low. So you can just copy and paste into another function, which I did here, to write to digit 2, and then basically, actually it should be digit 1, but anyways, to your next digit, and then write your A2, A1, and A0, so the proper bits, and then you can just do a function for all four of the digits in the OSRAM display. Alright, so now we're going to, now that we've got the microcontroller writing to the display, now we have to get the data out of the host computer and the flight sim and transmit it over the USB to serial converter, and transport it from there over to the microcontroller so it can be displayed on our display. And we're just basically going to write a real simple function based off of the code from the ATmega. If you go down to their UART section, I have real simple examples of writing bytes, or actually in this case we'll be receiving bytes. We'll be writing it from the C# program, which I'll do after this. But we'll be writing bytes from the C# program, sending it over the USB virtual COM port to the microcontroller, and it'll be receiving. So we'll be writing a little initialization function, and then which will turn on the receiver right here. We'll set the baud rate, and then we'll just set, keeping it real simple, we'll set the length of the data bit, which will be 8, and then 2 stop bits. And then you just have to make sure that when we do our C# program that we match our baud rate, match our 2 stop bits, and just make sure everything matches so you have good communications. Alright, so we'll do the UART initialization program. Be no return. Alright, so when you go to the 324 data sheet, and we're trying to set the baud rate, initialize the baud rate. Basically, because it comes from the factory, the 324 chip comes from the factory with the internal clock set at 8 megahertz, and then it uses a divisor to bring it down to 1 megahertz. So under the UART, you can look for under the example section here. We know our chips running at 1 megahertz, and in this case we'll set the baud rate to 2400, so UBRR will be equal to 25. So it just depends on what baud rate you want to set it at. You'll just change the UBRR values, but in this case we'll do 25. Hence the UBRR value here at 25. Alright, so basically this is right out of the, almost out of the data sheet for UART initialization. Around here, setting the so basically these two lines just set the baud rate. Then we're going to enable the receiver. Basically turn the receiver on, turn the transmitter on too. We're not going to be using it, but what the hell. It's there. Alright, next line and final one will be setting 2 stop bits and the bit length to 8. Alright, so this line is our stop bits. Equal to and our bit length equals 8. Like I said, we'll have to remember these when we do our C# program. Make sure our baud rate matches, stop bits matches, and bit length matches. That should be it for the initialization. And then, which is, this is like bare bones, but you don't need a lot just to get functionality. And then in our main loop, I've already stuck the receive function in here. You can go to the 324 data sheet here, go to the example. And should be pretty similar. Basically waiting for checking the flag, make sure it's not busy, and then reading the bits that are coming into the buffer. UDR0 is the buffer. Also don't forget on your functions, we're going to be using the 324 comes with 2 UARTs, 0 and 1, and basically I'll go back to the wiring diagram, the pinout. Right here, this is for there's a receive transmit 0, then receive transmit 1. So your UART 0 is here and your UART 1 is here. We're just going to be using the 0, and we'll just be wiring up a power, ground, and just this one wire to this receive function. To this receive pin, so we can receive our data through the USB to serial converter from the C# program. And that's what the in the continuous while loop. We'll just be sitting there spinning. It'll constantly be monitoring, waiting for data to come in, and then when we get the byte in the buffer, the UDRO here, then we're going to insert that into our write digit 0 function, and we'll write out whatever it sends, whatever comes down the line. We'll write it out to that first digit, the 0 digit on the OSRAM display. Alright, so I did a make all, and I've got some problems here. I forgot to do my prototype for my initialization function. Has no return and no input parameters. Oops. And because I wrote this before and I changed the name of my initialization function, and then I used a different one when I actually called it. Up here, alright, so I'm calling the initialization function for the initialization function for the UART, and then like I said, the rest will be accomplished inside the while loop. Alright.